Hello dear students, in this video we are going to solve this question. Let's see what happens when the temperature of the following equilibrium system is increased. So general chemical equation is given and enthalpy change is given. And to solve this question we have to understand Le-Chatelier's principle. Le-Chatelier's principle says that if any change in the reaction conditions for the equilibrium system occurs, then it will counteract that change. Means here, let's say in this question, temperature is increased. So the equilibrium system will work in such a way that it will try to decrease the temperature. It will shift the position of equilibrium and or it favors the reaction, the forward reaction or the reverse reaction, such that it counteracts the change. So here enthalpy change is given. So we have to understand that this enthalpy change is for the forward reaction, because in the equilibrium, forward reaction and the reverse reactions both occur at the same time. But here this enthalpy change is for forward reaction. Why? Because when some reaction occurs, after that it attains the equilibrium, and in this state, at this equilibrium state, what happens? The forward reaction and the reverse reaction occurs at the same rate. Means here the enthalpy change will be zero. Neither the heat is evolved nor the heat is absorbed by the system. So this enthalpy change is for this reaction which has occurred before the equilibrium system. That's why this enthalpy change is for the forward reaction. So here you can see that this enthalpy change value is negative, means forward reaction is exothermic. Because if enthalpy change is negative, the value of enthalpy change is negative, then it shows that reaction is exothermic. That's why forward reaction is exothermic and reverse reaction will be endothermic. Okay, so here the position of the equilibrium. So temperature is increased and that's why system will try to decrease the temperature. That's why it shifts the equilibrium in such a direction that it can reduce the temperature. And if this forward reaction is exothermic, we can write like this. To the forward reaction we can write like this, that A is a reactant, it converts to B product and it releases heat, because in case of exothermic reaction heat is evolved, right? So when temperature is increased, heat is given to the system, right? So heat of the system increases, so it tries to decrease the heat. So if forward reaction occurs, then the heat in the system increases because the heat is evolved here. So that's why it goes in the reverse direction. Means now the equilibrium system tends to go in backward direction. It favors the reverse reaction. So means, or we can say, the position of the equilibrium shifts to the left. So answer can be A option or B option. So here you can see the next part of the question is reaction rates of the forward and reverse reactions. And we have already discussed in the previous chapters that if we increase the temperature of the system or any reaction, then it will increase the rate of the reaction. So here at the equilibrium state, reverse reaction and the forward reaction both occur at the same time. That's why this increase in temperature will increase the rate of the forward and the reverse reactions both. So it will increase the rate of the forward and the reverse reactions. Means answer should be A option. Let's check the mark scheme. Yes, you can see here mark scheme also shows that A option is right. So this is the whole concept behind this question. If still you have any doubts, you can ask me in the comment section, and please subscribe my YouTube channel. Thank you so much for watching. All the best.